Hey everybody, it's Mr. Jakar again. Today we're going to be looking at 7.4. We're going to be looking at solving systems of nonlinear equations algebraically and graphically. So you've done solving systems of equations in the past where it's two straight lines. Now we're going to look at scenarios where they're not two straight lines. So let's look at this one first. So we want to solve this one graphically, and then we'll confirm. No, we're just going to do it graphically here. So you're going to want to use like some technology here to help with this. But first thing I want to do is I want to rewrite both of these. So I want to call this 1 and this 2. So for equation 1, if I add the 3x squared to the other side, it'd be 3x squared plus y squared is equal to 9. And for number 2, do the same thing. I'll have x squared plus 2y squared is equal to 10. Okay. Now, both of these are ellipses. So I'm going to go ahead and divide everything by 9. And in this case, I'll divide everything by 10. So I have x squared over 3 plus y squared over 9 is equal to 1. X squared over 10 plus y squared over 5 is equal to 1. Okay, so both of these have a center at 0, 0. So that's going to be important. We got centers at 0, 0 and 0, 0 there. Okay, so we don't have to worry about like shifting things around here. Just to help with my graphing purposes, if this is my a squared is 9, that means a, if I take the square root of that, is going to be, well, technically plus or minus 3. Okay. And in this case, b squared is 3. So I'm going to take the square root of that. So I get b is equal to a plus or minus root 3. So that means, quick graph for that one, from my center at 0, 0, my first graph is going to go, my major axis is in the y direction. So I'm going to go up 3. Yeah, up 3 and then down 3. Okay. So because of these points, I've got, whoops, 0, 3 and 0, negative 3. For b squared, I'm basically going to have root 3, 0 and negative root 3, 0. Now, the thing that helped that in terms of my graphing, both of these are about 1.73. So I'm going to go 1.73 is about right here and about right here. So here's my first ellipse. Okay. So then I'm going to find, so it says here, okay. Sorry about that. Okay. Then I do the same thing over here. I got a squared and b squared like this. So a squared is equal to 10. So I square root that so that a is equal to a plus or minus, I'm just going to root 10, but I'm just going to go right to the decimal number in that case. So it's going to be a 3.16 comma 0 and negative 3.16 comma 0. And b squared is equal to 5. So when I square root of that, that's going to be plus or minus root 5, which is going to go 0 to 2.4, 2.24, and 0, negative 2.24. Okay. So I'll graph those real quick there. So I've got 3, so 1, 2, 3, a little bit extra. So 1, 2, 3, and a little bit extra. 1, 2, and a little bit extra here, and then right here. So we can see graphically, we're going to cross 4 times. My solutions are going to be here, 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 and here. Okay. So you're in a case like this, I can't do this by hand. You're going to have to go to some kind of technology. So for like example, you can go to Desmos and do all this, or you can do this using your Conics app in a TI-84. Personally, I like Desmos because it's just easy to type it all in. So we're just going to go, let's see here. Do we want to do that? Sure, we'll do that real quick. So it's x squared over 3, y squared plus over 9. So give me 1 second on this. Okay, and so now I have it in Desmos. You can see the 4 points of crossing at right here. Okay, so we're basically getting plus or minus 1.26 and plus or minus 2.04 or 2.05. Okay, so it's 4 separate points, but if I want to kind of simplify that a little bit, I can say plus or minus 1.26 plus or minus 2.05. Okay, so again, that's a positive 1.26 here, positive 2.05, but then I can go positive, negative. I can go negative 1.26, positive 2.05, and then I can go negative, negative. Okay, so that's these 4 intersection points. And that's mainly our goal. We want to find intersection points, whoops, let's do that, but between our graphs and our intersection points between our 2 functions. Okay, So y equals natural log of x plus 2 and y equals x squared minus 4. So we got a natural log function. So that function's natural log is going to shift left 2. So normally a natural log would have a like a horizontal asymptote at y equals 0 or x equals 0. So in this case, it's going to go like this, where it's x equals a negative 2. So if I can plot some points in here, so for example, if I plug in negative 1 for x, I'm going to plot cross right here because the negative 1 plus 2 is 1, natural log of 1 is 0. Okay. If I need some more points, I can just plug in if I want, but again, go to your graphing utilities, help with that. So it's going to look something like this. So it's going to go here. Whoops, that. It's going to be a curve that goes here and crosses like that. Okay. So the next one is quadratic. That is just shifting down 4. So I'm going to go 1, 2, 3, 4. Here's my vertex. So for the rest of the graphing of that one, I can actually just do 1 and 1, and then leave we got here. We'll be crossing here and here at positive negative 2. Okay, so then I can just do my parabola here. And again, go to a graphing utility. We get 2 answers here. You can see that. We're going to have here and here. So going to go ahead and just do this in Desmos just so you can see that real quick as well. Okay, and there you can see we have this point right here is at 2.34, 1.47. And this point here is at negative 1.67 and negative 1.16. Okay, so that's all we're doing here graphically. So use the technology to help you out. So I got negative 1.69, negative 1.16. Actually, dot there, I don't need that. And 2.34, 1.47. Okay. So we got one more graphically, and then after that, we'll do some algebra ones. So this one is x equals 1. It's just a horizontal line. So that's going to be here. X equals 1. This one is going to give me a circle. Okay, so remember circle here. Y minus 1 tells me I'm going to have a center at 0, 0. This is r squared, so my radius is going to be 7. So in this case, I've got 0, 0, then 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. And then 1, 2, 4, 5, 6, 7. Oh, wait, I forgot to shift everything. So, all right. Point's going to be here and here, here, and here. So, my bad. I forgot to shift it. Oh, my God. Not paying attention either. Scratch all that. We're going to get rid of, tell you what, we're just going to get rid of all of this right now. Didn't pay enough attention to the shifting on that. That was my fault on that one. So here's x equals 1. Okay. The center is not at 0, 0. I don't know why I wrote that. The center is at 0, 1. So I'm going to go here. And from here, I'm going to go 1, 2, 3, 4, 5, 6, 7 up. 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4, 5, 6, 7 down. 3, 4, 5, 6, 7 to the left. So there we go. Pretty good there. So in this case, we want to find our points here that it crosses. Those are my 2 solutions right there. Now, the problem is it says it wants the exact answers. Here's the limits to graphing, and depending on that. We're not going to get the exact decimal numbers here, or we're not going to get exact values because we're just going to get decimal numbers. So instead, let's use our elimination or substitution methods to find this. So for example, if x equals 1, that could just substitute here. We could solve for y. So that's going to be 1 squared plus y minus 1 squared is equal to 49. Okay. Now I could take y minus 1 and distribute it out, but I don't think I want to do that because that's going to make it more work for myself. Instead, I'm going to work with this just being y minus 1 squared, subtract 1 on both sides. So y minus 1 squared is equal to 48. And then I can square root both sides. So I get y minus 1 is equal to the plus or minus square root of 48. So real quick, I could just do it off on the side. I break it down. It'll turn into 4 radical 3. And my last step is to add 1 to both sides. So I get y equals 1 plus or minus 4 root 3. So what does that mean for my solutions? They happen at the point 1 and then 1 plus 4 root 3, and then 1 minus 4 root 3. These are my 2 points there. Okay. So let's go ahead and do a couple more. Let's see, two more algebraically. So we're just looking for where can they make things a little bit faster for ourselves. Looking for relationships that we can set up easily. So here we have xy is equal to 2. I'm going to rewrite this for y. Y is equal to 2 divided by x. So once I have that, I can now do substitution right here. So x squared minus 2 over x squared is equal to 3. So if I square that, that'll be x squared minus 4 over x squared is equal to, you know what, I might as well just do 2 because I know where it's going. I'm going to subtract the 3 the other side, make it equal to 0. I don't like having x squared on the bottom, so I'm going to multiply everything here by an x squared. So if I do that, I'm going to have x to the 4th. I'm going to do this one next because then it'll be minus 3x squared, because then when I distribute to this, it's going to cancel that out. So I'm left with a minus 4. This is a quartic that is pretty straightforward to solving, because following the pattern of x to the 4th x squared has to have an x squared and an x squared in here. That multiplies to a negative 4, but adds to a negative 3. That's going to be a x squared minus 4 and an x squared plus 1. So now I could set these up. I got x squared minus 4 equals 0. So x squared equals 4, and I square root, so I get x equals a plus or minus 2. The other one, I get x squared plus 1 equals 0. So x squared equals a negative 1. But when I square root that, that doesn't work. Okay, so what I have is 2 possibilities for x right here. Now I'm going to go back to this original equation. I'm going to find y, because remember, the goal is to find points on the graph that they cross. So in my first case, I'm going to have 2 divided by 2, which gives me 1. In my second case, I got 2 divided by a negative 2, which gives me a negative 1. So that means my 2 solutions are 2, 1, and 2, negative 1. Remember, because x was, 2, 1, and negative 2, negative 1, because that's my 2 x's here, and the resulting y's from plugging those back in. Okay, last one. I'm going to do this one with elimination. You notice this one from earlier. Okay, so in this case here, I first, to do elimination, I want to get everything over to the same side like this with my x's and y's. So that's going to look like 3x squared plus y squared is equal to 9. And then x squared plus 2y squared is equal to 10. For elimination, I'm just going to treat it like my normal linear functions. Like, for example, if I multiply everything here by negative 2, I can eliminate y squareds. So I do that and I distribute here. So it'll be negative 6x squared minus 2y squared equals a negative 18. And then I have x squared plus 2y squared equals 10. Combine these so that these cancel out. I'm going to have negative 5x squared equals a negative 8. Right? Yeah. Equals a negative 8. Divide both sides by a negative 5 so that x squared is equal to an 8/5. And then I square root both of those. So when I do this, it'll turn into a plus or minus, it'll be 2 root 2 over root 5. When I rationalize this, multiply both the numerator and denominator by root 5, I'm going to get 2 root 10 over 5. So that's plus or minus 2 root 10 over 5. So what that means is if I plug this in, I want to go back to one of my equations. I want to solve for y, so I'm going to do this one. So I'm going to go y squared is equal to 9 minus 3 times 2 root 10 over 5 squared. Okay. Now, make it a little bit easier on myself. I know that since that's x squared, it's just going to go back to this, the 8 over 5. So I can just leave it as y squared is equal to 9 minus 3 times 8 over 5. So that's y squared is equal to 9 minus, it'll be 24/5. So when I turn that into over 5, this will be 45/5. So that's going to turn into a positive 21 over 5. And then I square root that. So y is equal to a plus or minus, square root of 21 over 5, which when I rationalize it is a plus or minus square root of 105 over 5. Okay, this whole thing is right there. So I don't have to go and take my negative version of this in here because it's just going to come out the same answer, the plus or minus root 105 over 5. So I actually have 4 points, but they are plus or minus 2 root 10 over 5, plus or minus square root of 105 over 5. Okay, and remember, this is representing 4 points. So it's basically positive, positive, and then positive, negative, and then negative, positive, and then negative, negative. Okay, and that's it for our solving. Again, we're finding those intersection points. So that's it for today. Take care, everyone.